Hello, so today's video is the second video tutorial on compound interest and depreciation. Compound interest is where something increases in value over time, whereas compound depreciation is something that decreases in value over time. So the first video was focused on compound interest. This one is going to focus exclusively on depreciation. Okay, so I've got 4 questions of different difficulty levels here in the question generator. So if any of the questions that you are working on look like one of these 4 questions, then you can follow through the example to help you. I'll come back to the question generator at the end. Before we do the 4 examples, as always, I've tried to have a think about the kind of things that you need to be comfortable with before you do this topic. So finding percentages of amounts, decreasing something by a percentage, converting between decimals and percentages is really important with this one. And then also particularly for the last example that I'm going to go through, you will need to know what you're doing with powers and roots as well. If any of those areas are something that you don't understand or find tricky, I suggest going away and having a look at those before looking at this video. Otherwise, the content that we're going to cover might be quite confusing for you. So, 4 examples. So a house was bought for £220,000 and its value depreciates. You might see that word, it just means decreases by 6% each year. So with these sorts of questions, if you just work out 6% of £220,000 and then multiply that by 3 and then take that away from your answer, you're not going to get this one right, because the decrease in value at the end of 1 year is always taken into account with any following percentage decreases. So what I mean by that, I'll do this the same way as I did the compound interest questions first, and then I'll show you how you're going to do this question using a multiplier. So at the start of year 1, the value of the house is £220,000. So we're going to work out the depreciation, so how much value that house loses in the first year, and then take that away to find us what the value is at the end of the year. This one over here I should have written start. Okay, so we're going to do £220,000 and we're going to find 6% of that. So if I did, where's it gone? There we are. If I did 220,000, divided that by 100 to find 1%, times that by 6 to find 6%, then that's going to be 13,200. 13,200. So now if I did 220,000 take away 13,200, that tells me that the value at the end of the first year was £206,800. Now the value at the end of the first year is the same, becomes the value at the start of the second year. We can do this 3 times, so I'll just write out the third year there as well. Okay, so now I want to find 6% of 206,800. So 206,800 divided by 100 to find 1%, and then times that by 6 to find 6%, gives me £12,408. So now if I just work out the value of the house at the end of the second year by doing 206,800 take away the 12,408, and that tells me that that's 194,392, which becomes the value of the house at the start of the third year. So now I'm going to divide this by 100 to find 1%, times that by 6 to find 6%, which tells me that in the third year the house loses another £11,663 and 52 pence. So just I'm now going to do the value of the house at the start of the third year, 194,392, take away the answer, and that tells me that at the end of the third year that's £182,728 and 48 pence. So that's compound depreciation. If I just want to demonstrate a point here, if you found out 6% of 220,000 divided by 100, times that by 6 to get that 13,200, and then multiplied it by the number of years, you're assuming that the house loses the same value each year. This would give you your total decrease in value. 220, 1, 2, 3, take away the answer. So that gives you a slightly different figure. What we've done there is we've worked out simple interest, whereas the correct answer was using compound interest here, £182,728.48. Okay, now to the nearest pound, like this question says, we're just going to finish off the question, £182,728. Okay, now that's the long-winded way, but if I just copy this down again, and we scroll down a little bit, I'm now going to show you the kind of more advanced way of doing it. Now, last time we're decreasing each year by 6%. So watch out for these, because the original amount, which in this case is £220,000, is 100%. Now at the end of the first year, to find out at the end of the first year, end of year 1, I'm simply going to I need to find out the multiplier first. So because it's a decrease, I'm taking away 6%. So that tells me that at the end of each year, let's move this calculator up here. That tells me that at the end of each year, my house is valued at 94% of what it was valued at the start of the year. So if I start by just doing 220,000 and I multiply it by 0.94, that's going to tell me how much my house is worth at the end of the first year. Now whatever the answer is to this, if I then multiply it by 0.94 again, that's going to tell me what it's worth at the end of the second year. And then if I multiply it by 0.94 again, that's going to tell me what it's worth at the end of year 3. So actually what I could do is I could just do 220,000 multiplied by 0.94 to the power of the 3, which is the number of years. And if I did that on my calculator, I should get the same answer. So where's my mouse gone? 220, 1, 2, 3 times 0.94, this to the power of buttons here, and then what we're going to do, oh sorry, that's 0.094, to the power of the number of years, press equals 182,000 £728.48. So to the nearest pound, that's £182,728, which is what I got up here as well. So using multipliers is a lot quicker and easier, and it's going to help you get to the more tricky questions as well. Okay, let's go to another example. So this one here, Emma buys a car for £3,900, and then for the first 3 years it loses 22% of its value, and then every other year after that it loses a further 16% of its value, and we want to work out the value of the car after 8 years. So firstly, the original value of the car is 3,900, and for the first 3 years, at the end of each of those years, it's going to be worth 78% of what it was at the start, because the original 100% take away 22% is 78%. Now that as a multiplier is 0.78. So because that's happening for the first 3 years, I'm going to do that to the power of 3. Now that gives me the value of the car at the end of the first 3 years. Value at end of 3 years. Now whatever that value is at the end of 3 years, to find out what that is worth at the end of the 4th year, we're going to multiply that by 100 take away 16 gives you 84%. This here as a decimal is 0.84. So the value at the end of the 3 years, if I multiply it by 0.84, that will tell me how much it is worth at the end of the 4th year. And then we keep doing that until we found out the total at the end of the 8th year. So because the first 3 years are taken into account by this 0.78 to the power of 3, the remaining 5 years, the difference between this 3 and this 8, it becomes worth 84% of its original amount. So actually the calculation is 3,900 times 0.78 to the power of 3 times 0.84 to the power of 5. So I'm just going to put that in my calculator. 3,900 times by 0.78 to the power of 3. On your calculator, the little cursor's just flashing at the top here, and if I put a times in there, it does it as part of the power. So please make sure you remember to press right so your cursor goes back down to the bottom, and we're going to multiply that by 0.84 to the power of 5. Press equals. That tells me that at the end of the 8th year, that car is worth £774 and 1 penny. If I do it to 2 decimal places, but this is asking to the nearest pound, so that's going to be £774, and that's it. Okay, last 2 examples. Now this one here, you're not given any values. You might sometimes be given a value, told that a ball is dropped from, I don't know, 50 meters, and each time it bounces up to a certain percentage of the previous height. If you are not given a total height, you can make one up. It doesn't matter. That's not the important bit, because if I change the height, the height of each bounce will change, and I'm only interested in the bit that is 15% of the original height. So you can make up a value, it's absolutely fine. So let's say, let's give the original height, the height from which it was dropped, I suggest, just because it works nicely with percentages, doing 100 meters. So I'm interested to find out at what point it is below 15% of the height. So I'm going to start by just finding out what 15% of 100 is. 15% of 100 meters is going to be 15 meters. So I'm interested to see the point at which, after how many bounces, that ball reaches a height below 15 meters. So to do that, I'm going to do the original height, and if I multiply that by, in this case, 0.6, we are already given the height it kind of bounces to, so it reduces in height by 40% each bounce. So If I multiplied it by 0.6, that would tell me after the first bounce. If I multiplied it by 0.6 squared, it would tell me after the second bounce, 3 would be the third bounce, and so on. The way I suggest you do these questions is if you just write in your calculator 100, that's the original height. If I press equals, the calculator will now store that answer here in the most recent answer, and that gets updated every time you press equals. So if you do anything with your answer, it then uses the most recent answer in the next part of the calculation. So if I pressed answer, in there is 100 meters at the minute. So after the first bounce, if I then times it by the 0.6 and press equals, that will tell me what the height is after the first bounce. What you can then do is just every time you press equals, that's now going to give you the height after the next bounce, and we're looking for the value that's below 15. So after the second bounce, it's not pounds, it's meters. The ball bounces to a height of 36 meters. After the third bounce, it's 21.6 meters. After the fourth bounce, that's going to be 12.96 meters. So it is after the fourth bounce that height is less than that 15 meters. So make sure you actually answer the question and say after the fourth bounce. And that's it. Okay, one more example. So Paul buys a car for £3,400, and we're told after the 4 years the car was worth £1,259. We're being asked to find that percentage depreciation. Okay, so this is similar to the fourth example in the compound interest video that I did. The first thing that you're going to do is you want to work out the multiplier but to get between those two numbers. So to do that, we're going to do the new value actually I'm going to call this the combined multiplier. We're going to do the new value and we're going to divide it by the old value. So that tells me that I'm going to do the new value is not always necessarily the largest value, because he's lost money on this car. So it's £1,259 divided by £3,400. So over to my calculator, 1,259 divided by 3,400. That tells me that the multiplier is 0. Because this isn't a final answer yet, I would suggest writing everything out. Okay, so that tells me that after 4 years, the car is worth 37%, because that as a percentage would be 37% of its original amount. So the old value multiplied by, we don't know, this is after 4 years. We want to know the rate of depreciation per year, which we're going to represent by writing x. Now that has been raised to the power of 4 because there were 4 years, and that's going to give me my new value. So putting these bits of information in, I know that my old value, 3,400 multiplied by x to the power of 4 is equal to 1259. Then what I've actually done over here is I've divided both sides by 3,400. So when I do that, I know that x to the power of 4 is 0.3702941176. So to find out what x is, I'm actually going to do the inverse of doing something to the power of 4, which is to find the fourth root of that number. Let's move my calculator. Not resize it. There we go. So if I do the fourth root of both sides, that will tell me at the end of each year what value have I got left of the original value at the start of the year. So again, that most recent answer has been stored in my calculator. So just above the power, x to the power button, there is a root button, and in there I'm going to put 4, and then inside I'll put the most recent answer. So that tells me x is 0.78000756, which as a percentage is going to be 78%. Now be very careful here, because that is not the value of depreciation. That's what I have left of the original 100% after taking away the value of depreciation. So to find out my depreciation, let's move the calculator again. I'm simply going to do the original 100%, take away the 78%, which gives me 22%. That tells me that the car has lost 22% of its value each year for the 4 years that we had it. And that's it. Okay, so what I'm now going to do is very quickly talk you through this question generator. So when you open the file, you must click, enable content or enable macros in a little yellow ribbon that appears at the top, and then all the buttons will work. So what you can do is, we've concentrated today on repeated percentage decrease. The other video I did was repeated percentage increase. You can get a mixture of these by clicking there. You can focus on a particular type of example that we've done, or increasing difficulty, and when you've got the hang of them, you can get a mixture of all the types of questions, and if you're getting those right, that shows a really good understanding. If you want to make it even more tricky for yourself, you can include decimal percentages, so that will help you. Why hasn't that worked? There we are. That will give you percentages that are not whole numbers, so 17.6% for example. You can click on these to get the answers one at a time, or you can show them all at once. You can have a play around, I'm sure you'll figure it out. But that's it. I'll put a link to that file in the YouTube description so you can download it and get some practice. Thank you very much for watching. Bye bye.